Hello, my dear students. Welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's topic, please do subscribe my channel. So, my dear students, today's topic for the lecture is anode rays and the discovery of proton. In the previous lecture, we have done about the cathode rays and the discovery of electron. The electron is negatively charged particle, but on the whole, the atom is neutral. That means there must be some positive charged particles also in the atom, which has risen the curiosity among the scientists to find out that particle. If there were the negatively charged cathode rays in the discharge tube, then there must be anode rays also. So let me write some introduction. First of all, I'm writing since electron. I'm writing since electron is an essential component of an atom component of an atom and is negatively charged and is negatively charged, but on the whole atom is neutral. Atom is neutral. That means there must be positively charged particles also in an atom. If there were if there were cathode rays in discharge tube, then then there must be some invisible anode rays also. So it was a scientist named Goldstein who have found the anode rays. So Goldstein, the name of the scientist was Goldstein, who performed the experiment in 1886 and found the anode rays. How did he found that? He perforated cathode. Perforation stands for making a hole or making a canal in cathode so that if there were any anode rays, they pass through that hole or canal and strike the fluorescent screen which is just placed behind the cathode. If we got some impressions or scintillations of fluorescent screen, then there must be some anode rays also. So let me first of all make a diagram for you to make a better understanding. I am making my discharge tube first. Here I am taking cathode having perforation in it, a hole in it. Now I have connected my cathode with an external circuit. I know that my cathode is negative charge and my anode is positive charge. Now I am completing my circuit by connecting it with a high voltage battery. Now we have to place a fluorescent screen behind the cathode. So let me label my diagram first. Here's my anode, here's my cathode, That's my fluorescent screen. What's the function of fluorescent screen? When any radiation, when any rays strikes the fluorescent screen, it produces some impressions or scintillation on it. That's the fluorescent screen. So now, what will happen? First of all, this is my high voltage battery. This is my high voltage battery. So I'm writing when the circuit is switched on, the anode rays will originate from anode and travels towards cathode. The rays will pass through the perforation or the hole, pass through the perforation of cathode and will strike the fluorescent screen, producing scintillations or some impressions on it. The production of scintillations or impression on fluorescent screen confirms the presence of anode rays. This was the observation of Goldstein. Let's come to the diagram. What will happen when the high voltage current is passed? The rays will originate from anode and will travel towards the cathode. They will pass through the scintillation and will strike the fluorescent screen, due to which some impressions, some scintillations are produced on fluorescent screen, confirming the presence of anode rays in the discharge tube. So, let's talk about the features, the characteristics, or the properties of the anode rays. So I'm writing properties of anode rays. The first property is they travel in straight line. Just like cathode rays. The second point, anode rays also rotates the small fan placed in its path which confirms that anode rays also possess solid material particles. This was the second observation, which comes out to be the properties of anode rays. Now, the third point. The anode rays also gets deflected in electric and magnetic magnetic field, and direction of deflection is such that solid material particles of anode bears positive charge. Let me explain this point through the diagram. This is my discharge tube. This is my discharge tube. That's my cathode over here with a negative charge. That's my anode over here with a positive charge. Now I am putting my two poles of magnetic field on the sides of discharge tube. That's the positive pole. That's the negative pole. Now what will happen? Anode rays are traveling towards the cathode, but once it's enter the magnetic field, it gets deflected towards the negative pole. Now it's again going towards the cathode, but in the magnetic field, it gets deflected towards the negative pole. Now it's again deflected towards the negative pole. It's again deflected towards the negative pole. It signifies that the particle of anode rays are positively charged. Now, these rays can pass through thin foils but blocked by thicker foils. The fourth point, these rays can pass through thin foils but gets blocked by thicker foils. Now let's talk about the charge to mass ratio of these positively charged particles. Firstly, the charge to mass ratio of these positively charged particles was different for different gases. In case of cathode rays, the charge to mass ratio was constant for different gases. But in case of positively charged particle, the charge to mass ratio was different for different gases. It confirms that. What does it confirms that? It confirms that anode rays are not emitted by anode but they are emitted by ionization of gas molecules when high energy cathode rays strikes them. Let's come back to the diagram. What is happening over here? The cathode rays are traveling towards anode. It got counteracted by the gas molecule in its path. The ionization of gas molecule will take place, due to which this gas molecule will now emit the anode rays in the direction towards cathode. Now, the sixth point, the mass of positively charged particle is virtually the same as that of the atom from which they were derived. I am writing the mass of the positively charged particle was virtually the same as that of the atoms from which they were emitted during ionization. Now the seventh point about charge to mass ratio. The charge to mass ratio of any positive particle was very much less than that of charge to mass ratio of electron. Now, atom is neutral. That means positive charge particle and electron will have the same magnitude of charge but in opposite signs. So, where will be the difference then? The difference will be in their masses. I am writing the charge to mass ratio of positive particle is very much less than that of charge to mass ratio of electron. Now the charges are balanced, that is, the magnitude of charge is same, but their signs are opposite. So what's left? Our mass is left. Now mass is in denominator. The mass is in denominator, so it confirms that mass of positive particle is much greater than the mass of electron. So now let's talk about the final point, eighth. So it was Sir J.J. Thomson in 1906. J.J. Thomson in 1906 found that charge to mass ratio of positive particle emitted by the hydrogen gas is maximum among all gases. So J.J. Thomson has taken the positive particle of hydrogen gas, to be the fundamental positive particle, has taken positive particle emitted by hydrogen gas to be the fundamental positive particle and named it as proton. So Sir J.J. Thomson got the charge to mass ratio of positive particle emitted by hydrogen gas to be the maximum. So he has taken the positive particle of hydrogen gas to be the fundamental particle or the fundamental positive particle and named it as proton. So that was lecture for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class, then he or she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.